fast. 747 jumbo jet has just rolled off the production line.
To stop production of the A380 in 2021.
Imagine spending $432 million building a single aircraft and then watching airlines refuse to buy it. That's exactly what happened to two of the most jaw-dropping engineering achievements in the aviation history, the Boeing 747 and the Airbus A380. These weren't failures, they were engineering miracles, and yet both production lines are now dead. They are victims of their own success. So what killed them? The answer has nothing to do with the planes themselves. To know why these planes were killed, you have to understand why they existed. You have to understand how the airlines thought about flying in the 1960s, the 80s, and the early 2000s. So stay with me, because by the end of the video, you're going to understand why and how the economics of aviation completely flipped the script on these giants of the sky. Back then, for airlines, the hub and spoke was the dominant model. The idea was simple. Instead of flying from every city to every city, you would funnel passengers through massive central hubs like London, Dubai, Singapore, Los Angeles, and many others. Here's where the 747 changed everything. In 1966, Boeing was essentially dead into building it. One trip, the legendary CEO of Pan American Airways and Boeing's Bill Allen made a handshake bet on a golf course that would reshape the world. Tripp wanted a plane so big it would make flying affordable for the average person. Allen agreed to build it if Tripp agreed to buy it. The result was the Boeing 747, the world's first wide-body jet, carrying over 400 passengers when its rival carried barely 150. The 747 was so huge that Boeing actually designed the front hump, the iconic upper deck, not as a first-class lounge, but as a cargo compartment. They genuinely were not sure passengers would fill all the seats. The lounge came later as a marketing stroke. Fast forward to 2000, Airbus was watching Heathrow, Frankfurt, and Dubai choke with congestion. Slots were nearly impossible to get. Their solution was to build a plane so massive it would require fewer flights to move the same number of people. That was the A380, with a capacity of 853 passengers as maximum density, a flying cruise ship with bars, showers, and beds in the first class. Both airlines and regulators loved the concept. Slot-constrained airports actively lobbied for this aircraft, and for a while, it worked perfectly. For decades, the 747 was the undisputed king of aviation. It drove down ticket prices so dramatically that transatlantic travel, once reserved for the wealthy, became accessible to the middle class. Between the 1970s and early 2000s, the 747 was the backbone of every major long-haul airline. British Airways used them, Lufthansa flew them, Singapore Airlines, Air France, United Delta, Qantas. The list goes on like a who's who of global aviation. In the early 2000s, jet fuel cost was in the range of 70 cents to 90 cents per gallon. Running 4 massive engines wasn't a financial death sentence it would become later. The A380 launched commercially in 2007 with Singapore Airlines, and for a moment, it felt like future. Flying on one A380 was an event. Emirates went all in, ordering 123 A380s, more than any other airline. The aircraft became a status symbol. But here's the critical detail. Both these aircraft were optimally profitable only when flying fully or near full capacity. The 747 needed roughly 70 to 80% of the load factors to break even on the route. The A380 needed even higher, often above 85%, just to cover the operating cost. As long as those routes were packed, the math worked. But the moment demand reduced, even slightly, the economics became brutal. In 2008, oil prices spiked to a record of $147 per barrel. Jet fuel cost went from manageable expense to consuming 40 to 50% of airlines' total operating cost. And operating 4-engine aircraft suddenly looked very different. The 747 has 4 engines, the A380 has 4 engines. A twin-engine Boeing 787 Dreamliner burns roughly 20 to 25% less fuel per seat on comparable routes. That's not a rounding error, that's the difference between the profit and bankruptcy on a narrow margin route. Every additional engine not only adds the fuel burn, but maintenance cost, inspection cycles, spare parts inventory, and certification complexity. The maintenance of a 4-engine aircraft can cost 3 to 4 times more as much as to maintain a twin-engine aircraft. And it wasn't just 2008. After a brief dip, fuel prices remained structurally higher than they ever were in 1990 and early 2000s. The economics of the large 4-engine jets were never same again. The airlines started doing the math. Why fly one A380 with 500 seats when you could fly two 787s with 280 seats each, reach more destinations, and actually use less fuel per passenger? The hub and spoke model, the entire foundation that justified these planes, began to crack. If fuel was the economic killer, then there was a regulatory change that was the strategic killer, and almost nobody outside the aviation industry knows about it. It's called the ETOPS, Extended Range Twin Engine Operational Performance Standards. For most of the commercial aviation, there was a rule called the 60-minute rule. According to this rule, twin-engine aircraft were not allowed to fly routes where they would be more than 60 minutes away from the diversion airport. Over vast oceans, that was almost impossible to comply with. So transatlantic and trans-Pacific routes essentially required 3 or 4 engines. This is why the 747 dominated the intercontinental routes for so long. It wasn't just about size. It was the only aircraft legally and practically viable for the long oceanic hops. But in 1985, the FAA granted the first ETOPS 120 approval to TWA for Boeing 767. And over the following decades, as twin-engine reliability became statistically near perfect, we are talking about engine failure rates at less than 1 per million flight hours. Today, Boeing 787 and Airbus A380 fly with ETOPS 330 approval, meaning they can fly routes where they are up to 5.5 hours away from the nearest diversion airport. Airlines now no longer needed 4 engines to fly long haul. They could operate the same profitable Tokyo to London route with 2-engine plane that cost dramatically less to run. The regulatory moat protecting 4-engine jets had completely evaporated. Here's where the aviation model did a complete 180 degrees. Boeing and Airbus had actually placed opposite bets on the future of flying. According to Airbus, it believed hub and spoke model would intensify. More mega hubs, more congestion, more need for massive aircraft. So they doubled down on A380. Boeing believed in the opposite, that the passengers increasingly hated connections. They wanted to fly direct from smaller cities to smaller cities, skipping the hubs entirely. That's called point-to-point flying, and it's the entire philosophy behind the 787 Dreamliner and 737 MAX family. The data has been unambiguous, and Boeing was right. The number of non-stop city pairs worldwide has grown dramatically in the last 15 years. Airlines like Finnair, ANA, and Qantas have opened routes that would have seemed impossible in the hub and spoke era. Think Heathrow to Perth, direct operated by a twin-engine 787. For A380, the consequences were severe. Airlines had bought it assuming hub routes would stay packed. But when passengers could fly direct, they chose direct. Hub traffic at some airports plateaued or even declined. Airbus received its last A380 order from Emirates in 2019, and it was essentially a rescue deal to avoid killing the program even earlier. Without Emirates, the A380 would likely have ended production years sooner. The 747, meanwhile, had already been declining in passenger service through 2010s, with most units migrating to cargo operations, a role where its massive belly capacity remained genuinely unmatched even today. And then 2020 happened. When COVID-19 grounded the global airline industry, carriers were forced to make a brutal triage decisions. Which aircraft to defend, which aircraft to fly when traffic returns? The answer was almost universal. Retire the 4-engine jets early. Airlines like Lufthansa, Air France, Singapore Airlines, and Qantas all accelerated A380 retirements by years. British Airways sent its entire 747 fleet to the desert with almost no notice, ending an era that had lasted more than 5 decades. So what made this a point of no return? When you park a complex 4-engine aircraft For 18 months, restarting it isn't just expensive, it requires recertification, deep maintenance, and retraining. For many airlines, the math simply didn't work. The fuel saving from switching to two-engine was so compelling that COVID became the excuse and the force to make the switch permanent. Singapore Airlines, which had launched the A380 commercially, quietly confirmed it will phase out its remaining fleet before the end of the decade. A plane that debuted as the future of aviation will likely be completely gone from passenger service within the next 10 years of its commercial peak. So here's the brutal truth about jumbo jets. They were not killed by bad engineering. They were killed by a world that changed faster than the business models built around them. Fuel got expensive, twin engines got reliable, regulators caught up with technology. Passengers voted with their ticket purchases for direct routes over mega hubs. The 747 flew for over 50 years and equalized global travel. The A380 redefined what premium flying experience could be. These are not failures, they are victims of their own success, made obsolete by the very industry transformation they helped create. Here's the question I'll leave you with. The Boeing 777X, the next long-range widebody, is a twin-engine aircraft. The Airbus A350 is a twin. We are fully in the age of twin jet. But what happens when the next fuel price shock hits? What happens when airports like Dubai genuinely cannot handle more slots and the passenger demand doubles? Could we see a new generation of super efficient megajets rise again? Drop your answer in the comments. I want to know what you think. And if you want to go deeper on how aviation works, keep watching Coop Aviation.